we are going to explore piecewise functions. So our objective is that we can take certain functions, restrict the domain, and create a piecewise function out of it. So let's start with a couple functions, and then we're going to do them separately and then combine them. So these will be the graphs of functions on a restricted domain. So first of all, looking at y equals x squared minus 4, that's a parabola. We're used to graphing these. The negative 4 translates it down 4 units because it's outside of the square. And so what this graph will look like is it'll start at negative 4 down here. And if I put in, for instance, 1 squared minus 4 is equal to negative 3. Same with negative 1. If I square it, I get a positive. If I put in 2, I get 2 squared is 4. 4 minus 4 is 0. Same with negative 2. Negative 2 squared is also 4. Minus that is 0. And then if I go to 3, 3 squared is 9. Minus 4 gives me a 5. So up here. And same with negative 3. Graph this. And this is what the graph would look like if we didn't have the restricted domain. Now, to restrict the domain, what we will do is we will erase the part that is positive, because this says we only want the domain values, x values, that are less than or equal to 0. So we're going to stop the graph as we get to 0, and so we'll end up erasing this part of it, and the graph goes right there. And so we look at this half of the graph. So a restricted domain means you're only going to draw the graph on the x values that it lists instead of all the x values. Let's do the same thing here. This graph I could list as, if I wanted to put it in slope-intercept form, I could list it as negative x plus 6. And so if I start this graph at 6, again, I'm going to graph the whole thing first and then restrict the domain. So if I start up at 6, and then I have a negative 1 slope, that means down 1 over 1, down 1 over 1, and keep going. And so I would draw the graph, it would look like this. That's my line for negative x plus 6. Now if we restrict the domain so x is greater than 0, we don't want all these negative values, we don't even want 0. So we're going to erase this part of the graph and erase where it's at 0 and put an open dot to represent the fact that it doesn't actually include 0. It does include x values like 0.2 and 0.375, so all these decimals in between, but it does start just after 0 and have the domain go from there. So what we're now going to do is take those two, and these two graphs, we're going to combine them onto one graph. This is called a piecewise function. This is the format we use, where we say the function is equal to this set of rules based on this domain. So this domain, x is less than or equal to 0, applies to this rule, x greater than 0 applies to this rule, and we combine those two graphs into one single grid. So x squared minus 4, if you recall, looked like this, where we had these numbers. And so this is what the graph looked like when we did it before. And we connect these. So we've got this half of the parabola. And then this graph, if you recall, was up here in open dot at 6, and then it went down from there. That is what a piecewise function looks like. It looks like the pieces of two, in this case, two different functions put on the same grid. So to summarize, what we want to make sure we do is take each of these rules and only apply the domain given to us there. So let's add to it a little bit of information. We want to find some values for this. And when you're looking at these values, what you're going to do is look for which part of the domain it fits into. So if I look at this negative 3, I want to look, and negative 3 fits into this domain. It's less than 0, so I'm going to put negative 3 in here. And if you recall, when we put in negative 3, we got out a y value of 5, and that's because we have negative 3, apply this rule, square it, subtract 4, and you get 9 minus 4 is equal to 5. So f of negative 3 equals 5. Well, 4, if you look at this one, it applies to this domain. It's not less than or equal to 0, it's greater than 0. So I'm going to apply the function for this function here to this domain. And so I'm going to do 6 minus the 4, and that gives me a 2 for that value. Notice that out here at 4, we're up here at 2. That was the y value right there on the graph. Now 100 doesn't show up on the graph. It's way off, x equals 100. It's way off to the right of this graph. But all we have to do is look back at the rules. 100 is greater than 0, so I'm going to put it into this one. 6 minus 100, using that rule, and I get negative 94. So these piecewise functions, look for where the x fits into the domain here and use that rule that goes with it. All right, now let's look at some other examples. We'll do a couple more here. Okay, so on these, we've got 4 pieces to it. We've got this horizontal line for this domain. We've got this horizontal line for that domain. We've got this parabola for this domain, and we have this line for this domain. Looks pretty complicated, but what you need to do is just be thinking, I want to think what it looks like, and then just restrict the domain. So let me start with red with this 2. Y equals 2. Remember, I'm going to draw the whole thing and then restrict it. So y equals 2 looks like this horizontal line here. Okay? And if this says I want just y equal to 2 when x is less than negative 4. So I'm going to erase all of this until I get to negative 4, and I'm going to put an open dot there because it's not or equal to. All right, let's do y equals negative 5. That's a horizontal line also. Let's do this one in green. So I'm going to start with y equals negative 5 down here. It's a horizontal line down here. And now what I'm going to do is restrict the domain to not include 0. So I'm going to erase this part and put an open dot on 0. And then it does include the negative 4. So I'm going to erase this part, and I'm going to put a solid dot here to represent that it does include that point as we get to it. Let's do the next one. This is a parabola translated. You could do it on your graphing calculator if you'd like, but I'm going to do this just translating, and I'll do this one in purple. So this one, it's translating the parabola. Negative x minus 2 means it's going to go a positive 2. Remember, on the inside of it, it goes the opposite direction. So you can go over 2 and then down 1 for my vertex of it. Okay, this is where I get my u to go on it. And so if I put in other values close to that vertex, if I put in 1, 1 minus 2 is negative 1, squared is 1, 1 minus 1 is 0. Same thing happens if I put in 3. 3 minus 2 is 1. Squared, you get 1. 1 minus 1 is 0. Let's put in 0. We go 0 minus 2 is negative 2. Squared is 4. 4 minus 1 is equal to 3. So I'm going to go right there. Now notice my domain says stop there. Stop at the 0. So I'm going to get this part of the parabola coming down like that. Now I want to take it all the way out to 4. So I'm going to see what I get for 4. 4 minus 2 is 2. Squared is 4. 4 minus 1 is equal to 3. So I'm going to get a here. Notice the symmetry. We're going to talk more about that symmetry as we do more with parabolas, how that is reflected. And I'm going to stop it at 4, including those 2 points, so I put solid dots on them. Now let's do this last one here. A good idea, by the way, here's a probably hint for, especially for these lines. If you want to do a line, all you have to do is instead of starting at negative 4 and going up 2 over 1 and up 2 over 1, instead start the point at that 4. I'm going to put in 4 into it. So wherever the domain lists it for you, put those values in to start it. So I'm going to put 4 in. 2 times 4 is 8. 8 minus 4 is 4. So I'm going to start at 4, comma 4. So 1, 2, 3, 4. And I'm going to put an open, let's do a different color. So let's erase that in a minute. Let's do this one, we'll do this one in black. So we're going to start at 4, 4 with an open dot because it does not include it. And now my slope goes up 2 over 1 from there, up 2 over 1. I draw my line going like that, showing that it goes on forever past it. So for this kind of piecewise function, you think ahead of time, what is my graph going to look like? And now I'm going to restrict the domain. Horizontal line, restricted. Horizontal line, restricted. Parabola, restricted. And then just a line, restricted. Restricted on these domains for these rules. Let's try another one. Let's try this one down here. All right, let's go back to red for this one. I'm going to do all of it in red for this one, okay? So we're getting used to this idea of restricting the domain. So what I'm going to do is draw a horizontal line at 5, okay? And I'm going to stop it at -3. So horizontal line, and then here at -3, I'm going to stop it and put an open dot. So that's how that graph looks. Now, this is a line between -3 and 2. I'm going to go ahead and draw it using the y-intercept and the slope. So I'm going to start this graph at 1, and I'm going to go up 1 over 1 for the slope. So up 1 over 1, up 1 over 1, and notice it stops at 2, so stop the graph right there. And now we'll go back to -3, so down -1 over -1 is also equal to a slope of 1. So down 1 over 1, down 1 over 1, and then I go one more time to here, and a solid dot there. And so that's what my line, stopping at -3 and at 2. And then lastly, this is going to be a horizontal line. I just want to go greater than 2. So I'm going to start it at 6, down here at -2, put an open dot, and draw a horizontal line for that piecewise function. So let's do one last thing here and look for what g of 0 would look like. Again, when you have a problem like this says, look for where that x value, 0, fits into these domains. 0 fits in here between -3 and 2. So what I would do is put the 0 in for that. I get 0 plus 1 is equal to 1. So what we have with piecewise functions is you go ahead and do each piece according to the domain given. So you might have to draw, in this case, 3, the previous case 4 different graphs, but restrict it according to that domain. This last problem down here, this will be a problem, we'll use this grid in class and do a problem together for participation.